from unit 2A. So, first thing, which of the following is considered rational? What does rational mean? Yeah, it could be turned into a fraction, or it's a terminating decimal. So like if I put it in my calculator, it would stop after a certain amount. So if I have something that goes on forever and ever and ever, is this a rational number? No. So it can't be that. Radical 2, and it's also, it has to be a perfect square. If it's not, it's irrational. So would this be a rational number? No. No. 0.25. Yes. Yeah, what is 0.25 as a fraction? 1/4, right? So we know it can be turned into a fraction. Pi is irrational. What is a domain? What's a domain mean? X, right? So X would be all your first numbers. What would the other numbers be? Your Y, which is your range, right? Okay. So this is back to domain and range. So a clothing company uses the function f of p, where p is the number of people working in a clothing store, to model the amount of income coming in from people working there. A reasonable domain. So domain is referring to what letter? The x values, right? And so what letter are they using for x this time? P. P. So they're saying that p is referring to the number of people, right? So we need to figure out what can be referred to as a number of people. So rational numbers, that includes fractions, right? So that includes fractions. Can I have a fraction of a person? No. Positive and negative integers. That means I can have whole people, but I can have negative people. Can I have negative people working? No. Real numbers includes everything, rational and irrational. So maybe some people forgot. Rational and irrational numbers are all considered real numbers. In Algebra 2, you'll learn about imaginary numbers. So I can't have a square root of 2 of a person, so it couldn't be this. I could have 0, 1, 2, etc. people. So your answer is A. So that's the answer. Yeah. Mm-hmm. Okay, next one. So this is the same thing. So there's still, it says a wild horse runs at a rate of 8 miles an hour for 6 hours. Let y be the distance in miles the horse travels for a given amount of time at x hours. The situation can be modeled by a function. Which of these describes the domain? So what does domain mean again? X. So right away, which one's Y? All the ones that have y's, right? Then we need to think about the x. What do they tell us the x means? Hours, right? So in this situation, we know that it's what's the least amount of hours? So 0 is the least amount of hours, and then what's the most amount of hours? 6. So what would your answer be? A. 0 to 48 would be your miles, and miles would be your range. Does that make sense? All right, next one. How do I know it tells me when the relation is not a function? How do we know if it's not a function? Yeah, so we're finding in this case when does the x repeat? So in these lists of numbers, is there a 0 x coordinate? No. Is there a 1? Yes. That's my answer. So just pay attention when it says not and when it says it is a function, because they may use that. A lot of us forgot about these, this is right from your formula. So you're given this, but you're not given what each of these mean. So remember, recursive talks about like a reoccurring dream, right? Recursive, reoccurring. So like the same dream I had yesterday, I'm going to have tomorrow, right? So it's basically like what has happened. This means take the term before. So when they're talking about this means the y value or the term before. And this means the D is your difference. What's being added or subtracted each time. So D stands for difference. So we would use this in the case of like it's just basically telling us what pattern is going on. That's what recursive means. Explicit is more of a rule. So in order to find like the 100th term, N stands for the term number. So if I'm trying to find the 100th term, I would put 100 in right there. D is still the difference, so what's being added and subtracted each time. A1, what does A1 stand for? First term, so when your x is 1. So that's kind of like a little rule. So in this case, a to the n minus 1 means take the term before. A to the n means they would say, okay, define the fifth term. That's what that means. So the n is just your term number. So that n and that n are the same. Kind of confusing. So everyone get at least this part right here. Okay. Then this one, we talked about what does the n stand for? This right here? Term number. Okay. And then what does the d stand for? Difference. What's being added? Okay, so here's like it in action, right? And here's an example, and here's 4 different terms. So first of all, at term 1, how many blocks are there? 2. What about term 2? 6. This one? 12. 10. And then 14. Cool. So first of all, let's figure out these ones are written in just slope-intercept form. So if we're doing slope-intercept form, what would be my slope? What's being added each time? 4. Now remember, your y-intercept is when x is what? 0. This is when x is 1. So if I had term 0, if this is being added by 4, how do I get the term before 2? Subtract it. So what's 2 minus 4? Negative 2. So your y-intercept should be negative 2. So which one has that? 1 or 3? 3, right? So we know that this has got to be correct. Then this is in recursive form. And I know that because if you see that a to the n minus 1, you know they're talking about recursive. So they're telling us our first term is 2. Is that correct? Right here, first term.
Yeah.
First term is 2. And this is saying to get the next term, I take the term before and add 4 each time. Is that correct? To get this term, I would take the term before and add 4. Mm-hmm. So your answer is 2 and 3. Does that make sense? So you are given that little excerpt thing on your formula. This one? It is your slope. This is saying your slope is 1. So that means 1 is being added each time and 4 is your y-intercept. Yeah, and they did that on purpose to try to mess with you. All right, this one's from your spring or your fall break packet. So what's your y-intercept here? 6. So that's when your x is 0. Which ones don't have x being 0? 26. This one. Then this one. Then what's your slope?
6.
Oh, -2. -2 is your slope, right? And so we can even just look at these to see which one's going down in general.
With the following student, please report to the main desk. Teacher, please report to the main desk.
This is going down. That one's going down. If you needed to be more specific, if they're asking a question, they're pretty close. Remember, we just find the slope of 2 points. Does that make sense? All right. So we're trying to find which equation represents this. So first of all, what is your y-intercept here?
4.
Positive 4, right? Your y-intercept, your b, is 4. Which one doesn't have 4 as their y-intercept? See how they have 4 as their slope? They're kind of measured here? Then the only difference is the sign. So is it shaded above or below? Above. So what's your answer? 1. And remember, to check your work, you can always take a point. So you can take like 4, 0 and make sure it makes sense. So like if I were to plug it in this one, I would plug in 0 for y and 4 for x. And this will make sure it's correct. So I have 0 is greater than or equal to -12 plus 4. And I end up getting 0 is greater than or equal to -8. Is 0 greater than or equal to -8? Yep. So I know I did it. But only check your work at the very end when you're all done. Does that make sense? All right. What does this mean? What am I doing here?
You're plugging in into x.
Plug in 4 into x. And so if it said f of x equals 4, that would mean plug it in for f of x. But if it just says f of 4, you're just plugging it in for x. So what's 2 times 4?
8
plus 6?
14.
Okay, to find the x-intercept, you plug in what for what?
0.
Yep, it's always the opposite. So 0 for y. If you're finding your y-intercept, you plug in 0 for what?
X.
All right. A lot of people got the wrong answer because they give you the slope and the y-intercept. But what are they looking for?
The
X-intercept. And to get that, we plug in 0 for which one? And you can also do the cover-up. If you remember that. So anything times 0 is what? 0. So I can just kind of ignore it. 4x equals 40. How do I get x by itself? And what do you get?
So the x is something that also be like, could you use the quadratic formula to find that, or would that just
No, because it's not a quadratic function. So if it had a square right here, then yes, but it's not a quadratic function.
So you couldn't,
No, because there's no square. If the square tells me, I can do all
but it
that.
has to be.
Mm-hmm. Sorry, here. How would I write this as a point though? Blank, comma, blank. Mm-hmm. Blank, comma, 0.
Good afternoon, Julie. My name is Raven Day.
Okay, so it says a satellite television company charges one-time installation fee. If you see one time, what does that tell us it is? The slope or the y-intercept? Y-intercept, right? Because y-intercept usually means like initial, one-time, starting point, and a monthly service charge. What would that be considered? Your slope, right? The total cost is modeled by the function y equals 40 plus 90x. Which statement represents the meaning of each function? Part of the function. So we know what number is going with the one-time installation fee. 40, right? So we should see that 40 goes with the one-time installation fee. We should see that the slope is that 90. And then it's $90 per what? What do they call it? Month. So X would be your months, because it's per whatever it is. And then Y would be your total. So in this case, total cost. So answer 2. So even though the 90x is not in front, as long as it has an x, it's still considered your slope. Does that make sense?
Yeah.
Cool. All right, rate of change. What does that mean? Slope. So they may give you questions that are look like a quadratic function, exponential, and they'll say, give me the average rate of change when x is 2 and when x is 5. So no matter what are you going to try to find with those 2 points? If it says rate of change. Slope, right? And so there's a couple questions on that in Saturday Academy, but if you see average rate of change or rate of change, you know you're finding the slope. What about y-intercept?
Initial starting value.
Perfect. What's each, every, per? What would that be considered? Slope, right? Rate of change, slope, and behavior we'll be going over unit 3. All right, what's a 10 considered? The y-intercept. So here, we haven't done this in a little while, unless you're in class today. So I need to get it in slope-intercept form because they're asking for the slope. So first I need to get y by itself. So what do I need to do? Yep, subtract 2x on both sides, and you get negative 4y, don't drop that negative, equals negative 2x plus 20. Then what do I do? And so you end up getting your slope, I'm going to put that up here, negative 2 over negative 4. What does that reduce to?
1/2.
1/2. Because negative over negative just makes it positive, and this fraction reduces to 1/2. And then your y-intercept would be in negative 5. Is the getting in the line of this equation. So what 2 things do we need? If it's a line, we know it's linear, right? And so remember, on your test, it's not going to go by chapter like we've been doing in these sessions. On your test, it's just going to be a bunch of questions, and you'll need to pick out when you do each thing. So if you see in the line, you know it's linear. So what equation do we know that's linear? Y equals what? Perfect. So what 2 things do we need to find?
The slope and y-intercept.
Perfect. So let's find the slope first, or the y-intercept first. Where is the y-intercept?
Two. The y-intercept is the same law, but why do you need to find it?
What do you mean?
For the option choices, it's 2.
Yeah. So you wouldn't need to find it. I didn't even look at the option choices, but just in case, if you want to make your line. But if you want to eliminate them, you might as well just, this is so simple, you can just get the equation. But the first thing you should get is the slope. They all have the same y-intercepts. And so I'm going to use 2 points. And remember, if you're using points, they have to fall directly in the middle of the 4 boxes, right? So it doesn't matter which two I use, but I'm starting at the left one, and it's rise over run. So how much would I rise to go from this point to that point? 1, 2, 3. So I rise 3, and run how many? 1. And so it's positive because it's going up. So your slope would be 3 over 1 or just 3. So your equation should just be this. Is it coming back a little bit now? Yeah. Cool. All right, I think this is the last one. All right, Connor wants to attend a town carnival. The price of admission is $4.50, and each ride is additional 79 cents. So, which one would be your slope? Which one would be your y-intercept?
79 is
So each because 79 cents. So I know that 0.79 per an additional ride, and then the initial value is $4.50, right? Because that's what you're paying up front. So first of all, which answer choices don't have that? 1 and 2, right? Then we need to figure out how many rides. So we need to make sure the signs right. The signs are both the same, but if they could spend at most $16, that's one we have trouble with, right? If I could have at most $16, could I spend $17? No. Could I spend $15? Yes. So would it be less than or greater than? Less than or equal to, right? Now they want me to get R by itself. So what do I move first? 4.5 to both sides. And when you get that, you end up getting 0.79 R is less than or equal to, what do you get? And then what do we do? It's the last thing. How do I get R by itself? Divide. And does the sign flip? Nope, right? The sign doesn't flip because only when it's a negative coefficient. So I end up getting R is less than or equal to, and what number does it get? When you divide these. 14.5. Now, some people may say, okay, well, I would round up to 15. But if he only can afford 14.5 rides, because they're talking about rides, they're not going to let me go on a half a ride, right? I can't just pay half of 79 cents and go on a half a ride. So you have to round down. So how many rides could he actually go on? 14. So you kind of have to make sense of the problem. Is that the last one?
Yeah.
Awesome. So